remember this? It's the Blackstar HT5 that had that seriously bodged repair. So this amp was irreparable, and the customer, instead of paying the bench fee, he gave me the amp instead. So I'm quite happy with that, because I can create a project into this case, use the chassis. So what I wanted to do with this amp is to find out what we can actually do with this. Now, the amp that I built with the television tubes, we actually used a Blackstar HT5 head chassis, but of course we didn't use the transformers off the Blackstar. The only thing we used was the chassis and the case. So what I want to do with this project, I want to see if we can use those transformers. Now obviously this amplifier had a couple of tubes in it, and the output tube was a 12BH7, which was a twin triode tube, which doesn't draw much more current than a preamp tube. So the transformers in this amplifier are not massive, and so that leaves us very limited. So, you know, we're not going to be connecting up an EL84 to it, to the power transformer. I just don't think it'll take it. Also, we've got to take into consideration the heater supply, the filament supplies. The current draw on the filament winding will be limited, because nobody's going to build an amp and put a 5 amp filament winding when they've only got 600 milliamps of tubes drawing on it. So we need to check that, and so we're going to do some experimenting with this just for a bit of fun, just to see how far we can go with this. And I've got a few ideas for this amplifier, because rather than having triodes for an output stage, we'd be much better off with something more along the lines of a pentode. And I have got a few ideas in mind, so we're going to have a look. We're going to see what filament voltage is. Try and work out what we think the rating of the transformer is, how much HT voltage we've got, and we're going to do a turns ratio test on the output transformer. Right, I've got this out on the bench, and you can see the power transformer, and again going by size, that is a Blackstar HD20 output transformer, and you can see it's not much bigger. So the output transformer, you can see, is also quite tiny. That is a reverb transformer that we've got there, and you can see it's just a little bit bigger. So there's a 12BH7, and we've got a 12AX7. So we're expecting that filament winding from this transformer to be 12 volts. So you can see the windings coming in through here from the power transformer. So we've got a couple of wires there, a couple of red ones, got a green one which I think may be ground, I don't know, and then we've got the blue ones. I'd expect to see more than that really, but that's all we've got. So we're going to switch on, take it off standby. Let's just have a look what voltages we've got on this output tube. So we could do with finding a diagram of this tube, but I'm presuming that's the 6.3. I'm presuming that's filament, although we are to ground, so that may be half. 465 volts, my word. 13 volts. $465 volts on pin 1 there. Let me just get a pin out for a 12BH7. So here's the pin out for it, and you can see we've got the plates on pin 1 and 6, and we've got the filaments on 4 and 5 on there. to, let's just come out a bit. So let's, so I've put a cable in this amplifier to, in the input, because sometimes these JFETs and so on, you don't always, with these JFETs, you don't always get these amps to work properly. And if you remember when we did those tests for the Blackstar HT5 that club, I don't know what it was, that HT20 I've stripped down anyway, we were getting different voltage readings without the lead-in, without the input lead-in. So we've got 465 on that plate on pin 1, and obviously we've got the same on the other plate. That's a lot of voltage on there, a lot of voltage. Maximum ratings, DC plate voltages are 450 volts, you can see there. So a little bit over, but nothing to worry about. That's surprising. That takes a lot of voltage. You can see why they've used that tube actually, can't you? It's very robust. So let's have a look at the filaments. Sorry about that, rocking the camera there. 13.25 we've got across pins 4 and 5. So as I said, when I tested that to ground before, I'll be getting half of it because of the center tap. Yes. So we know it's a 12 volt filament, although we expected that, given the fact that we've got a 12X7 and a 12 BH7. We've got 463 volts of plate voltage. That's a lot of plate voltage, a lot. But obviously we don't know what the milliamp rating of this transformer is. Now, given the fact that's quite that, let's go back to that filament voltage again, 13.29. So it should be 12.6. That's a little bit over. Not a massive amount, but that tells me that maybe that winding is not being massively loaded, which means there may be a little bit more room to load it, because we want to put different tubes in this, as I've said before. So yeah, so you can see, the just about see the meter now there. So if we check, if we just check pin, oh dear, let's turn the volumes. Oh, it's sprung to life. But for a second, it will only be for a second as well, because of course it's got that massive fault on it. So you can see now at 467, that's topping on there. And if we look at the filament voltages, you can see pins 4 and 5 on there. And you can see we've got 13.26 going on there. So a little bit over with that again, but that's not a problem. So now we need to do a turns ratio on this output transformer. But I just want to check what AC is on that winding there. $365 volts on the AC winding of the HT feed. Right, these 3 wires here are from the output transformer, and remember this amp is push-pull despite being only 5 watts. So we've got 2 windings and a center tap. Be careful when you're taking these off after you've just switched the amplifier off, as I have, because I had to wait over a minute for that voltage to drop down. When I put my meter on it, a few seconds after I turned it off, there was 187 volts. It took a good minute or so for that to drop down. So be careful, because this is the center tap, and it'll have the full HT volts on it. Even though it's switched off, it's still at 187, and it'll just give you a nip, but it's not a pleasant nip, is it? Right, so we've got those off. So we need to rig up the variac, and we need to rig up the meters and everything to do this test. We also need to remove those three there as well, these three, because these are the impedance, the secondaries. So there'll be an 8 ohms and a 16 ohms impedance on this amp. There may be on this data sheet, there may be some information. I'm just going to search for that. I've just done an impedance test on this primary winding of this output transformer, and it turns out that brown is centre tap and not red, according to that. So we've got, just shows you should never go by the colours. So 404 ohms we've got there on that one. So now if we go brown and red on there, you see we've got 482 ohms. So if we assume red is the centre tap, and we go red and black, we get 890. And of course if we go to brown we should have 400 again, because yeah. And if we go, yep, so that's telling me that brown is the centre tap and not red on there. I could actually just check that as well, although it's red's in the centre, but it just goes to show. So if I go to red and I go to pins 1, oh sorry, wait, yep, nothing, pin 6, yeah, I've got continuity there. And if I go to the black connection, I get, yep, continuity. So yep, so definitely without question, brown is the centre tap on there and not red. Always pays to check. So we need the black and the red wire to do this turns ratio test. We don't need the centre tap. And I've got the 3 wires off for the secondary, which we're going to connect another meter to. Basically what we're going to do is on the red and black wire, we're going to feed a voltage into this primary winding, or both of the windings, because obviously I'm not using the centre tap, so it'll go through both windings. And then we're going to put another meter on these secondaries that we've got here, and when we see 1 volt on these secondaries, whatever the voltage that we've put in on that reads will be our turns ratio. That's how it works in theory. Right, we've got this all set up, ready to do this turns ratio test. So we'll only be using a low voltage on this variac. The one thing to remember if you are going to do this, obviously you're going to use a plug top with bare wires, and you need to make sure you put that away as soon as you've done with it, because if you leave it lying around, how many times have you put the wrong plug in? And if you plug that in with bare wires, that won't be very pleasant. If they're touching, then it'll short your fuse box out, your consumer unit. You'll have to go back and reset it, and if you happen to be touching them, then you'll get a bite off them. So I'll always put that plug, if it's a plug top with bare wires, I always put that away straight away. I always do. I always make a rule of rolling it up and putting it back on the rack, because I'm a dummy and I often put the wrong plug in. Right, so let's start turning this up. So we've got 3 wires coming off that secondary, so we need to test those in combination. We start to go up and we're not seeing anything there. Why is that? Oh, that fool. It's because you've got it on ohms and not AC. There we are. And just adjust this meter because the light's shining on it, and I can see it through the camera. It's struggling to see that. So if we look at this one, we can see it. Just turn it around. So we've now got 1. We just need to adjust that so it's 1 volt. There we go, near enough. So 1 volt, so 19.96. So that's looking like about 20 to 1 there on that test. So we'll write that down, and that is the green and black wire that we've got there. And that was my pen falling on the floor. So now just cut the voltage, and we are going to check black, and where's the other one? Red. There. Right, let's go again. So black and red this time we're testing. And you can see now we've got much more on that. There we go. So we've got 28 to 1 there, I would say. It's near enough. 28 to 1. And you can see that now is red and green, and that is 64 to 1. Well, that was interesting results. Not one of the combinations came out as I expected it, the others were miles out. Now what I've done, I've actually connected on here and tested to make sure that, because sometimes when you do this, you'll test a winding and you'll get some ridiculous reading off it, and then when you actually connect the speaker to it, you don't actually get any sound from it. But I have connected all combinations and we get sound from all of them by testing them off the board. So green and black, if we look there, was 20 to 1, and if we square that, and at 8 ohms that comes out at 3200k, not what I was expecting. 16 ohms it would come out at 6.4k. Red and black came out at 6.2k and 12.5k, again 8 ohms or 16 ohms respective. But this winding of red and green came out at 32,769 at 8 ohms. So if I remove my thumb, that's what I wrote down before we started, 30k. So only one of those windings at 8 ohms, and at 16 ohms obviously that's double. Only one of those windings has come out as I expected it would, given the maths that I did based on the plate voltage and the plate voltage and the wattage that these tubes are drawing, and that's based on 7 watts. That's actually based on both sides of that triode. Normally you would base that on one side of the triode, which would probably then come out somewhere around that figure. So yes, that's a strange transformer. I think what I'm going to do now is trace back to the sockets for each wire and just see if I can see where they're wired to, and obviously the sockets are labelled on the back. So right, we've just got this board out and we're looking at these sockets, and if we align them that way, you can see that this is the 16 ohm socket. I'm sure it's stuck to my screwdriver. 16 ohm socket there, and then we've got the 1x8 or 2/16s for these two. So I've just done a bit of a check. Probably can't see on here, but if you see black there, and you can just see a trace going from how close we can get in, you can see a trace there. That trace goes to ground, So, and it's obviously it's ground on all the sockets, so we know that black is ground. So red is the sorry, that leaves red and green. So green, if we turn it over, we can see that green goes to the live on there, and we can see that that is 16 ohms if we line those up. Look, so green is 16 ohms and red is 8 ohms according to that. We'll just look at red. If we look at red there, and there's red's going off to those two sockets there, which is 1 times 8 or 2 times 16. So red is 8 ohms, and we need to write those down, don't we? Well, we would do if we had a pen. So red is 8 ohms and green is 16 ohms. So when we come to look at what we wrote down here, the turns ratio I thought would be accurate for this project is not. It's miles out, and the reason we now know that winding isn't correct is because it's red and green together, and we know black is ground, so red and green are irrelevant. So red and black, green and black. So red and black is 8 ohms, so that gives us a turns ratio times 8 of that's after it's squared, that figure gives us 6,272, and green is 16R, that gives us 6,400. So we know this transformer is a 6k primary from all that information that we've worked it out. It's a 6k primary. I must admit that has surprised me, but I don't quite know how they've done the maths on that. But of course you've got all this circuitry and gumph in there, who knows. But the normal way I've always worked those out, and they've always come out accurate to what's on the data sheet, is the way I do it. But that's come out nothing like. That's come out totally different. So I'm going to go away and do some head scratching now and wonder how they've come to those figures. Yes, interesting, very interesting. So anyway, we've got this board out. It won't be going back in. So if anyone wants one of these HT5 boards that's got the backboard, that is, with the sockets and the power socket on there, drop me an email and you can have that. This board obviously is tatered. We know that it's had it. So we want that'll be going in the bin, because it's got 2 large holes in it, although you can't see them from the top. Actually, under those fets, and there's 2 holes. So that's given us some figures to work from there with these transformers. The question is now, what are we actually going to put in this? What tubes are we going to use? Well, whichever tubes we use, obviously, because we still don't know the milliamp rating of these transformers, so we've got to be careful what tubes we do shove in here. What circuit shall we put in here? Probably do with something relatively simple, really. So what do you think we should put in this? What circuit do you think we should just have? Something similar like a champ circuit? The tubes are irrelevant, really. A 5E3 rather, if we're doing this in push-pull. Something like a 5E3 circuit, which is a 5E3 is basically a Fender Champ in push-pull. Probably something like that, of course, so we'd only end up with a volume and tone unless we put a tone stack in it. Of course, the problem always comes down to, using these smaller chassis, is getting all the components in. If we use a normal turret board, it just won't fit in this amplifier. What tubes do we use? That's the thing. We could use some preamp pento tubes maybe, but I can tell you now that the primary the primary impedance won't match up on the transformer for those type of tubes, which is how I'm wondering how they've got that down to a mere 6k. Because again, if I was testing that, I would expect that to be somewhere around about 30k, because most people that use preamp tubes, and people do build amps with preamp tubes as output tubes, and I have got 1 or 2 projects in the pipeline planned for that, they usually end up using reverb transformers, because they're usually wound around about 25k primary. Of course, you could use the Hammond transformers that I've used, that I'm actually doing this WEM PA40 project. You can use those Hammond 125D transformers because they have got quite a high primary winding on them, and you've got selective primaries as well on there, as we'll see in the video when that's finished. I can't remember whether I showed you that in part 1 or not. So I think that just about wraps it up. So leave it in the comments what you think this amplifier should be, what we should wire into it. It's a strange one. I don't know whether we'll be using that output transformer. A bit weird. I didn't expect to get a 6k primary with a 3.5 watt tube with 463 volts of plate, 463 plate voltage. Very strange. But anyway, I'm going to leave this one there now. We will be building something into this very soon. So thanks for watching, and you all take care, and I'll see you all in another video. Bye bye for now.